Some of the upcoming lessons make extensive use of interfaces, so it would be a good idea for you to have a general understanding of what they are and how they work. I touched on this earlier, so I'm sure you have some notion of what they do, but you're going to need to know a little more to really understand how programs set themselves up to listen to the mouse and keyboard. This is a simple class. It doesn't do anything, but it does extend the Canvas class, and it implements the runnable interface. I'm sure that you recall that any class implementing the runnable interface was required to contain a run method. That's how we've been doing animation. Keep the declaration of the MyCanvas class in mind while we go look at something else. This class creates an instance of the MyCanvas class and then tests it for being lots of things. This keyword, instance of, is a Java operator. This is not a method call, this is part of the language. It looks at the object to its left and determines whether it's an object of the type specified to its right. The type could either be a class or an interface. As you'll see inside a program, they act pretty much alike. We know that a MyCanvas class is also a Canvas class because it extends the Canvas class. This means it can be treated in every respect just exactly like a Canvas object, although it may act differently under certain circumstances when you call its methods, but that's not where I'm going right now. The MyCanvas object is also a component object, because the Canvas class extends the component class and the inheritance is passed on down to the grandchildren. The component class extends the object class, so the MyCanvas object is also an object. Of course, this is no real stretch because every object in Java can trace its heritage back to the object class. You may want to take a look at the documentation of the object class. Among other things, you'll find methods that are shared by every single object in Java. It's interesting. One of these methods is toString, which converts the object to a string, which means that every object in Java can be converted to a string. But you knew that. If you write a class, but you don't write a toString method, your class inherits one. But I'm getting off the main subject again. The MyCanvas class is also a runnable object. Now, this is important. If a class implements an interface, then objects of that class can be treated exactly if they were objects of the interface type. The constructor of the thread class required a runnable object be passed to it, and any class implementing the runnable interface would satisfy that requirement. Here's one that could surprise you. The MyCanvas object is also an accessible object. You see, the component class implements the accessible interface, so the MyCanvas class, by inheriting the component class, also inherits the implementation of the accessible interface. All in all, the MyCanvas class inherits the implementation of 4 interfaces, all implemented by other classes in its heritage. An object of the MyCanvas class can be treated as any one of these. Now here's how you go about taking an object of one class and treating it as the object of another. It's all done by declaring a reference of the type you wish to have and then storing the address of the object in that reference. Java is very picky about what it allows you to store in a reference. If you try to put an object into a reference to something that is not anywhere in the object's heritage, it won't let you do it. Error messages will pop out. Believe me, I've tried. There's no way to fool it. Here we have the assignment of a MyCanvas object to a reference to a Canvas object. Using this new reference gives you access only to the Canvas stuff in the MyCanvas object. Then the address of the MyCanvas object is stored in a reference to a runnable object. The compiler goes along with you on this because anything you can store in a MyCanvas reference is going to be a runnable object, so you can certainly store it in a runnable reference. Notice that although runnable is an interface, we can declare ourselves a reference to it just like we can a class. Here we create a new MyCanvas object and store its address directly into the reference to an interface implemented by a superclass of MyCanvas. You see, the MyCanvas class completely inherits the implementation of all interfaces by all superclasses just as if they had been implemented locally. If you're making an assignment in a direction such that the compiler can't be positive it will always be correct, you'll have to cast it. For example, in this assignment statement, a class other than the Canvas class could implement the menu container interface, so it is possible that this won't fit. If you force it to fit by casting it this way, and it turns out to be wrong, it'll be detected when the program is running, and an exception will be thrown and halts execution. This program will compile and run this way. Now, all of this is called polymorphism, and it's a central characteristic of object-oriented programming. It becomes extremely useful to be able to morph objects into different types of things and use them in different ways. Being able to extend classes, implement interfaces, and morph objects is the basis of all object-oriented programming in Java. You'll pick up some other object-oriented ideas as we go along, but most of them are only bookkeeping to make these fundamentals work. Let me show you an interface. As you can see, it's very much like a class. The keyword interface is used to define it, and it has methods without any code in them. There is no constructor. In fact, there is no executable code of any kind. Just like a class, you put a public interface in a source file of its own with the same name as the interface, and then you compile it into a class file just as if it were a class. Here's a class that implements the cruncher interface. This is sort of a minimal implementation. To satisfy the requirements of the interface, bodies for all three methods are provided. And that's it. We'll be implementing some interfaces in the upcoming lessons.